Good morning. Welcome to Physics World. Today we discuss about chapter 1, force. Every day in our life we do so many activities like walking on the road, jumping, running, writing, kicking the ball on the football ground, throwing the ball in the cricket, hitting the ball with the bat. All these are different activities, but one thing is common, and that is force. Without it, all these activities are not possible. In ancient time also, many people were eager to know that what is this force. Ancestors were believed that all the natural changes happening in the nature like sunset, sunrise, change of seasons are due to force, an invisible force. In 19th century, the father of modern physics, Albert Einstein, also told that the universe is working only because of some invisible force. The Big Bang explosion happened because of the force. So that justifying that all the activities happening because of force only. So today our point of discussion is what is force. Suppose you have a table and a person standing on the floor and he is pulling the table in this direction. Okay, then table moving towards left side. Suppose the same person in another case he just pushing the table, then the table move in the forward direction. You want to open the door, what do? You pull the door. You want to close the door, what we do? Yes, we push the door. So in all these examples, we are applying the force actually. Here also applied the force. In this case also have applied the force. In the door example also have applied the force. In all these cases, we have done either pulling or pushing the object. So force is simply defined as push or pull on a given body. It's a push or pull on a given body, that is force. Now we should know that yes, many types of forces are there in nature, and because it's forces, many changes happening to the body. Sometimes body change its state due to application of force. Sometimes body changes shape. Sometimes with the force you can change the speed of the body. Okay, before going to deep in the discussion of all these changes, first of all we have to know about what is types of force. Basically we have two types of force. One is contact force and second one is non-contact force. Contact, the word tells you that contact means when you want to apply this force, the two bodies should be in contact. Non-contact force means the two bodies should not be in contact, still force is applied. Okay, first coming is contact force. How can we tell a contact force is existing? See me, I am holding a chalk piece. I want to hold the chalk piece and I want to write on the board. If I want to hold the chalk piece, my muscular force are acting to hold this chalk piece. So in this holding condition, my fingers are in contact with this object. So the muscular force, what is making able to hold this chalk piece is contact force. A person walking on the road by holding a suitcase, walking in the forward direction. In that case also, he is in contact with the suitcase and he is holding the suitcase with his muscular force, and muscular force is a contact force. You want to throw a ball, so what we do? You don't throw a ball like this. You stretch your hand in front of you and you throw the ball. So when you're stretching the hand, the muscular force acting on the ball and through which the ball is thrown. So generally the muscular force is generated because of muscular cells in our body. The muscular cells has the ability to stretch and contract. So when you're stretching your hand, the muscular cells will stretch in the hand, the chest, and other parts of the body. The muscular cells will be contracted so that you will be stable, and you can stretch the hand and you throw the ball. So in that way, the muscular force is generated and making the bodies to move or making the bodies to have some change. So that is contact force. Muscular force. Now coming to non-contact force. In non-contact force, the body should not be in contact. Still, the force is applied. Guess what is non-contact force? Maybe you studied in your lower grade, grade 7 or grade 6. Yes, you got it. Now I'll give a small clue to you. What is this? This is North Pole, this is South Pole. So what is called? Yes, this is called a bar magnet. A bar magnet. Now if you keep any iron material, like iron nail, when you kept near the bar magnet, what happens? Even the bar magnet not touching the iron nail is attracted towards bar magnet. So without in contact, still it is able to attract the iron nail. So magnetic force here is non-contacting force. Magnetic force is non-contacting force. Now I'll give another example to you. You know that when you drop any object, then what happens? It falls on the ground. Why it is falling on the ground? Everyone knows that because of gravitational force of the earth. Here also, when the body like a ball is falling on the surface, it's falling on the surface because of gravitational force. Gravitational force, and this gravitational force attracting the ball towards the surface. And this surface and the ball is not in contact. So gravitational force is also a non-contact force. After learning contact and non-contacting forces, let us go deep into the contact forces. You know how you are able to hold any object? Ask the question by yourself. See, I am holding the chalk piece again. How am I able to hold the chalk piece? Yes, earlier I told that because of muscular force I can able to hold the chalk piece, but only muscular force not the reason behind that. There is another force between my fingers and this object making me able to hold the chalk piece. How can I able to write something on the board? Means there is a force between my chalk piece and the board making me to write on it. How are you able to walk on the road? Sometimes suppose if your room floor is made of tiles and it is wet and you wanted to walk on the wet surface, then what will happen? You feel slippery. Sometimes there is a possibility of slip and fall on the floor. Why? At the same time, if you are walking on the road surface, there is no slippery. Happily you can walk. Why? So all these questions, only one answer, I think you got it, and that is friction. So friction. So friction is one type of contact force. So what is more about friction? Because of friction between my fingers and the chalk piece, I am able to hold it. Because of friction between the chalk piece and the board, I am able to write. Sometimes you observe that while we are writing with the chalk piece on the board, you hear some sound, some little high frequency sound, and that sound is also produced because of friction. You are unable to walk on the wet surface, earlier told, You felt slippery and you may fall because of water between your feet and the flow. Because of water between feet and flow, there is less friction, and because of less friction, you may fall. And you are able to walk on the road, I told, because you have huge amount of friction between your feet and the road surface. That's why you're able to walk. So in everyday life, what are the things we are doing? Most of the things only because of friction. Somebody asked me, if friction is not existing in nature, then what will happen to the nature? What do you think? Can you do the things what you're doing the things now? Not at all. It is not at all possible. You can't walk, you can't talk, you can't hold, you can't do anything. So everything will be stopped at a time. We all human beings just become like a normal bodies, lifeless bodies. So with friction only everything is possible in the nature. Now, what is friction? We have to define the friction. I told that force is pull or push on a given body. Then what is friction? See, there is an object having wheels, and this is moving on the surface due to this force F. Moving on the surface of force F. But as the friction is contact force, there is force acting between the wheels and the surface. So, and this friction force always acts opposite to the applied force. When applied forces increases, this friction force also increases. So friction generally opposes the motion of the body. But sometimes you have to clearly understand that sometimes friction support the motion of the body also. So that's why friction defined as, I'm defining here, it is opposing force which opposes relative motion of the body. See the word relative motion of the body. That means if the body is at rest, because of friction, body comes into motion. If the body is in motion, because of friction, body comes to stop. See this example once again. This body moving in the forward direction because of force F, and the friction force is increased, and we are not at all applying any external force there. Because of friction, after some time, the body comes to stop. So here, moving body comes to stop because of friction. Take another example. This is the leg of a person, and he wanted to walk on the surface or on the road. And you feel that when you are walking on the road, just observe, you are just pushing the road on the backward direction. You're pushing the road in the backward direction so that you're moving in the forward direction. So you're pushing the road in the backward direction like this. So this is your applied force. You're pushing the road backward. Suppose when there is no counter force in the opposite direction, then what happens, because of this force now you fall on the ground. But without falling, what is happening there? There is a counter force, which is a friction between the road surface and your leg. And that counter force balancing your applied force so that this point of contact becomes stable. So that happily you can walk on the road. So in this case, friction supports motion. So that's why I told relative motion. So it opposes relative motion. So when the body is in motion, it comes to stop. When the body is in rest, it supports the body to be in motion. We understand that friction is one contacting force. There is another contacting force also. Let me tell you. There is a ball on the ground, ground surface. And you know that ground is nothing but surface of the earth. And earth always applies gravitational force on the bodies. So because the gravitational force, the ball experiences gravitational force toward the center of the earth, and ball has to go inside the earth. But it's not going. It is stable on the surface. See, I am standing here. I am standing on the floor at the surface. So I should be attracted at the surface. Yes, I am attracted at the gravitational force. So I should go into the earth. Still I am not going. Why? Let me draw the diagram here. So a person standing on the earth surface, and the person is experiencing the gravitational force, GF, gravitational force. Still is not going inside the earth. Why? Because there is another counter force acting, and that force balancing these gravitational forces. And this counter force will be in the upward direction, and this counter force always acts at the point of contact. See this dot careful. This is called point of contact. So this counter force always at the point of contact, and this force always perpendicular to the point of contact, and that force is called normal force. And this is another contact force, normal force. So if you see this case here also, we have normal force at the point of contact. Here you have two legs. So the point of contacts are two. See, this is one point of contact, this is one point of contact. So from this point of contact, a normal force acting upward. From this point of contact, another normal force acting upward. So two normal forces are balancing this gravitational force. So in this case, one normal force supporting the gravitational force. I can say that N equals to gravitational force, GF, implies net force, F net, equals to N minus GF, equal to 0. That means net force acting on this ball is 0. That's why ball is stable on the ground. Here also 2n equal to GF, because why I said 2n, why I add the n, because the two forces are acting the same direction, so you can add up. So 2 plus n plus n, 2n, which is equals to GF. So if you take net force 2n minus GF, which is equals to 0. So net force acting on the person is 0. That's the person stable. That's why I am stable standing here and teaching you. So normal force is the contact force, always acts at the point of contact in perpendicular direction. Let me write the definition there. It is a contact force acting at point of contact and perpendicular to it. That is normal force. Sometimes you play indoor games. Say, you know the game tug of war, like two groups of people pulling the rope in two different directions, and who crosses the reference line, we declare that group is the winner group. Like this, there is a rope and persons are standing next to each other by holding the rope in one direction, and in other side also the persons are standing and holding the rope, and these persons are pulling the rope into towards the left side, so towards this direction, F1, and these persons pulling the rope towards the right side, say the force is F2. So they will keep a reference line like this, reference line. So what will happen, to which side of the group will pull the rope such a manner that the other side people will fall, then we say that that side people are winners. So here one thing you have to understand, that when the F1 F2 forces both are equal, then they won't move, they are stable, because net force acting them is 0. In the previous example as I told you, when one force is balanced by a counter force, then net force acting on the rope is 0. But when these two groups are pulling the rope with stronger forces, sometimes there's a possibility of breaking of a rope. So breaks. Why? Because there is a certain limit for the rope, and the force exceeds that certain limit, it happens like that. So how could you say that there is a certain limit for the rope? This is based on a particular type of force called tension, and this tension is represented by the symbol T. So here, when these three persons applying the force in this direction, see, left side direction, when they are applying the force in this direction, then there would be another force acting in the rope, by the rope itself, and that force is tension. See, tension exactly opposite to the force and equal to the force. Similarly, coming to this side, when they are applying the force in this direction, then there is a tension acting opposite this force exactly and equal to the force. So that these two tensions are acting in the rope always, and they balance the two forces together. And whenever this force F exceeds the tension, then the rope breaks. Either this force or that force exceeds the tension, breaks happened. So take another example. There is a support, it's a rigid support, okay, and it's a string. The string is connected to a mass, capital M. All of you know that each and every body has got weight. This body also got weight, and this weight acting is a downward direction, and the weight is mg. Weight formula is m into g, we know that. Now because this weight, the box M should fall because of the weight, but it's not falling. Why? Yes, you can say that because this string is supporting it. Exactly correct. String is supporting, but inside the string, the tension is supporting that weight. And how it is supporting, It is supporting by acting in the opposite direction. It acts in the opposite direction, and it cancels the mg force. Therefore, T equal to mg implies T minus mg equal to 0. So net force acting on the box is 0. That's why the box is stable. So in that way, tension is the force acting in strings and ropes, and it always acts opposite to applied force. See, in this example also tension is acting opposite to applied force. In this example also tension is acting opposite to applied force. So it is a force acts opposite to applied force. Okay, suppose take a rubber band. You are holding the two ends of the rubber band and stretching. Stretch means you are applying force in both the sides, but rubber band is not cut in the middle, because rubber band is also applying elastic force in the form of tension opposite your force. So it is counterbalancing your applied forces. But after some time, the rubber band breaks because your applied force exceeds the tension or the elastic force of the rubber band. So sometimes what happens, when you are in contact with the body, then only force is experienced. Sometimes when you're not in contact with the body, still force can be experienced, like we have studied in the earlier concept contact force and non-contact forces. In this category, there is another type of force which are acting at a distance. Means even though the source of force and the destination object are at a distance, still the destinated object experiences the force. Then we say force acting at a distance. Take an example. Number one, the type of force is magnetic force. Magnetic force. It is force acting at a distance, because if you take a bar magnet, earlier example, take an iron nail, both are at a distance. Still, the iron nail will come towards the bar magnet and attract it, because of magnetic force has that capacity. Even though object at a distance, still it applies the force. Take another example. Take two bar magnets, North Pole, South Pole, and again South Pole, North Pole. See, like poles. Maybe you learn in lower classes that like poles repel. Like poles means same type of force, same type of poles. So these like poles, when facing each other, they repel. They move away from each other immediately. Even though both are not in contact, both are at a distance, still they experience the forces by each other and they repel. So this magnetic force is called force acting at a distance. Now the question is that why it is happening like that? What is the reason behind that? Wait for a few minutes. I will explain you why these things are happening. Now second type of force, electrostatic force. Electrostatic force. You know the current. Current is produced because of moving charged particles. And these moving charged particles are electrons. So current is produced because of flow of electrons. See the word flow of electrons means charges are flowing. That's why current is produced. If you the other side, there also you can produce current, but not because of flow of charges. That because of charges are at rest. So if you are producing some forces due to charges at rest, then those forces are called electrostatic force. In this name, you see the word static. Static means rest. So charges, generally in physics, we use symbol Q for charge. Charge Q. If I don't write any sign, it is positive charge. If I write minus sign, it is negative charge. So this charge is at rest. This charge applies the force. This charge applies attractive force or repulsive force. If you take like charges, say, now I'm removing this negative sign, positive charge, like charges. And the like charges you are taking, they repel. Means both the charges are applying the forces on each other. If you take unlike charges, then they attract. They attract. So like charges repel, unlike charges attracts. Now the question comes that okay, you have introduced charge, but how could you generate this static charge? We have so many methods to generate static charge, and naturally we can generate charges. I will tell you how. Long back you heard about these examples in lower classes, like if you have a dry hair, take a comb and comb the hair and keep the comb near the paper pieces. What happens? This is the comb having teeth like this. Okay, this is the comb having teeth. Now these are the paper cuttings. When use this comb and comb the dye hair and keep near the paper pieces, what happens? The paper pieces attracted to this comb. The paper pieces attracted to the comb. Why they are attracted? Because of electrostatic force. Why this Coulomb generated electrostatic force? Because the Coulomb surface consists of these charges. If I make it little magnified, this Coulomb, say I magnified the Coulomb, one teeth I am taking. This is the one teeth of the Coulomb. One teeth of the Coulomb. This teeth consists of so many charges on it. So many charges on it. Because the charge, it attracts these paper pieces. Take another simple example. Again, you hold dry hair. You take inflated balloon. Take the balloon and put it on your hair and rub for some time. Don't apply more pressure on the balloon will blast. So, take the balloon, put on dry hair and rub for some time. And keep it on the wall. Automatically it attracts the wall. Stick for some time. Why? While you're rubbing, the charges are transferred to the balloon, and all these charges are accumulated on the outer surface of the balloon. Outer surface of the balloon. And when this charged balloon, when you keep on the wall, it attracts the wall and it stays there. That is static charge. See, these charges are not moving, they're stable. Still, they generate electric force. Understand? So, electrostatic force is nothing but the force generated by static charge, means charges are at rest. A great scientist called Coulomb explained electrostatic force mathematically, and he has given a force formula also. When you go to higher classes, you're going to study about what is that force and what is the force formula. Now, the third example. You know the third example. Just guess. Any body dropped freely, then what happens? It falling on the ground. You know that. Why it is? Yes, it's because of gravitational force. And it's gravitational force not acting when the body is coming towards the earth. Wherever you are there above the surface of the earth, still the earth applies the gravitational force on the body. So, if this is the earth surface, and this is the ball which has some distance, still the ball is attracted by the earth and falls towards the earth, and that attraction force is called gravitational force. So the third example is gravitational force. Now listen, some important points I'll tell you. Magnetic force is attractive or repulsive. It attracts, it repels. Attractive and repulsive. Electrostatic force, yes, attractive and repulsive. See, like charges repel, unlike charges attract. So it's attractive force, repulsive force. Now coming to gravitational force, is it attractive or repulsive? It is only attractive. Okay, gravitational force is not at all repulsive, it's only attractive. Earlier, I told you that in magnetic force, the bar magnet is attracting the iron nail even though it is at a distance. How it is possible? I told because of magnetic force. But how a body which is at distance experiencing the magnetic force? There is a reason behind that. That reason is field. Magnetic forces have magnetic fields. Let me show you how they are. So, magnetic field. So, this is the bar magnet, North Pole and South Pole. Whenever the bar magnet is placed in some area or some region, what happens? There are magnetic field lines. Magnetic field lines are the reasons for developing magnetic force. And these magnetic field lines move from North pole to south pole, like this, North pole to south pole. So many magnetic field lines will be there. I have drawn very less number of field lines, so many, like this. So to how far these magnetic field lines, these are called field lines, how far these field lines are spreading, to that much area the bodies have magnetic force effect. Suppose if I keep an iron nail like this here, this iron nail. Now if you wanted to make the bar magnet attract the nail, is it possible the nail to be attracted by magnet? No, because it is not in the area of field lines, that it won't be attracted. But now this is kept here. Now what happens? It is attracted because it is in the region of field lines. It's the region of field lines. So what I wanted to tell you that bar magnet attracting the objects even though they're at a distance, because bar magnet applying the force to some extent region from it. So this region, say dotted line, see the dotted line, this region is what called magnetic field. Magnetic field is a region which is having magnetic field lines, or you can say magnetic field is the region where magnetic force is experienced. So let me write the definition. It is the region where magnetic force is experienced. So as the iron nail kept here, it is experiencing magnetic force attracted, whereas here this one is not experiencing. That's why it will stay there only, it won't be attracted. Understand now? So why the forces acting at a distance? Because they have the field around it up to some certain distance. So in that region, any object is there, it will be experienced. Okay, and another important point, this field strength also. Field strength means the strength of the field. Means more the field strength is more the force value. Here in the magnetic force, more the field strength means more the attractive force or more the repulsive force. If you keep the iron nail here than here, then what happens? What's the difference? If you keep the iron nail here, at the pole side you have more number of field lines, so that the force strength is also more. Therefore iron nail attracts so much towards the bar magnet because of strong force. But iron nail kept beside like this, here the number of field lines are less. That's why even though it has the force, you can say relatively it is having less amount of force because less number of field lines are there. Okay, so magnetic field is the region where the magnetic force is experienced. I'll give some natural example to you. Suppose you are in a closed room. And you open the cap of a scent. Then what happens? Throughout the room, the scent smell is spread. Then I can say the room is a scented field. So if I want to get the smell, I have to come to your room. Then only I can feel the scent smell. If I'm outside your room, I can't feel. Similarly, if the iron nail wants to have the attraction force, it has to come to the field. If it is outside the field, it doesn't have any force. That is what magnetic field. Similarly, we have fields for all the forces. Earlier I told electrostatic force. Yes, it has electrostatic field. Electrostatic field. If you take this charge Q plus Q, and this charge has the electric forces like this. So this is the region. That is the region where the electric force is experienced. That means if you keep any charge here, some other charge if you keep here, this charge doesn't affect by this charge because it is outside the field. But if this charge here, yes, of course, this charge is affected by this charge. So electrostatic field is same definition. It is the region where electrostatic force is experienced. And now you can define gravitational field. Gravitational field, similar to these two types of fields, it is the region where gravitational force is experienced. So we are in the gravitational field region. That's why we are experiencing the gravitational force of the earth. If you go beyond the height, beyond the field of the earth, then what happens? The gravitational force of the earth becomes zero. That's the reason why whenever the scientists want to launch a satellite outside the earth, they will send the satellite to rockets with the speeds equal to escape speed. If the rocket doesn't have the escape speed, then rocket will be attracted by the earth's gravity and it fall. Sometimes you heard in the news channels also that some satellite want to be launched by Sriharikota, but it was failed. Rocket doesn't land correctly and fall on the earth. It's only because of it is not reaching the expected escape speed. So once the rocket gets escape speed, it will escape from the gravitational force and go to the space and launch the satellite. Okay, so in that way all the forces have fields.